If you thought, oh my days, binomial is so long, how can it get any longer? Guess what? They managed to make it longer. Now, they're going to ask you to do partial fractions first, before even doing binomial. So can you try it, please? Part A, you've got a fraction. I want you to try and express it in partial fractions, please. So, you're going to turn this into a over 1 plus x plus b over 2 minus x. Now, you could have done it the substitute way, you could have done it the coefficient way. I think the substitute way is probably the easiest one, so that's the one I'm going to go for. 4 minus 5x is the same as a 2 minus x plus b 1 plus x. If you sub x equals 2, you get minus 6 equals 3b, so b equals minus 2. And if you sub x equals minus 1, you get 9 equals 3a, so a equals 3. So that means you can rewrite that fraction 4 minus 5x over 1 plus x 2 minus x as 3 over 1 plus x minus 2 over 2 minus x. That's what you should have gotten after doing partial fractions. Now, in part B, it says, hence show that the cubic approximation of blah, blah, blah is blah, blah, blah. So to go from here to here, you need to apply binomial. To do that, you need to rewrite each of these as their brackets. You need to then apply binomial. And then, after doing that, you need to do this binomial minus that binomial. I know it's quite long. So, if you haven't done that, can you try doing that now, please? Okay, the first binomial, you're going to do 3, 1 plus x to the power of minus 1. That is pretty straightforward because your bracket already starts with a 1. Whereas in the other one, you're doing this. That's the bracket you're going to try and apply the binomial expansion to. So you need to take that a step further and do 2 to the power of minus 1 times 1 minus a half x to the power of minus 1. Lots of brackets, I know. But that is what you're going to do there. After applying the binomial expansion to the first bracket and after timesing everything by 3, you should have 3 minus 3x plus 3x squared minus 3x cubed. Usually, they only ask for the first 4 terms, or they only ask you to work up to the x cubed term. The second one is a little bit longer, but after simplifying all that, you should get 1 plus x over 2 plus x squared over 4 plus x cubed over 8. So now you're doing this minus that. And you should get 2 minus 7 over 2x plus 11 over 4x squared minus 25 over 8 x cubed. Okay, cool. The second part, the last part, state the range of values of x for which the expansion is valid. Okay, the expansion for 3 over 1 plus x is valid if the modulus of x is less than 1, where the other one, it's the modulus of x over 2 is less than 1, or the modulus of x is less than 2. You need to find the range that satisfies both of them. The range that satisfies both is the modulus of x is less than 1. This doesn't work for the first fraction. This works for both fractions. And that's how you implement and work with partial fractions with binomial expansion.